In this video, we'll continue working with triangle congruent shortcuts, SSS, SAS, ASA, AAS, and then there's one new one that we're adding on to our list today, which is going to be the hypotenuse leg congruence postulate. So this page will kind of help us remind ourselves what those shortcuts looked like. I'm going to start up in the top left corner. Actually, maybe I'll hide part of it so we're not super confused. So when I look at those two triangles, I see a bunch of congruency marks on the sides of the triangles. In fact, there are 3 sets of congruent sides, so I can make a conclusion that triangle ABC is congruent to triangle DEF. And I knew that because we've already learned about the side-side-side congruence postulate that says if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles will be congruent. Right below, we've got another set of congruent triangles. Be careful when we write this congruent statement because they're going to switch the letters up on us. I know triangle ABC is congruent to, well, A and D are both have an angle mark in the corner, so I know A and D line up. Then my next letter is F, followed by E. How did I know that? Well, I knew that because I had 2 pairs of sides, and the angle between those 2 sides was also congruent. Since the angle is included, that's by the SAS shortcut. So if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles will be congruent. And I know I'm going pretty fast through these, but I'm kind of assuming at this point we're already familiar with a lot of these shortcuts. We've got one more on the left side of this page, and then we'll do the 3 over on the right. I've got another set of congruent triangles. We'll call our first triangle ABC. Well, when I look at ABC, I've got 2 angles and the side between them. Same thing with my other triangle. I see 2 congruent angles and the side between them being congruent to my first triangle. So ABC is congruent to DFE by the angle side angle congruence postulate. That postulate says if 2 angles and the included side of one triangle are congruent to 2 angles and the congruent and the included side, then the 2 triangles will be congruent. All right, we're halfway done. I'm going to jump to the top right corner next. Here's another shortcut that we're already familiar with. Triangle ABC is congruent to triangle DFE. I knew that because I have 2 pairs of congruent angles and the side not between the angles. That's the angle side congruence postulate. So in words, if 2 angles and the non-included side of one triangle are congruent to two angles, and the corresponding non-included side of another triangle, then those two triangles will be congruent. Next one on our list is going to be brand new. So this one says, if the hypotenuse and the leg of some sort of triangle are congruent to the hypotenuse and the leg of a second triangle, then these two triangles will be congruent. I've got a hint as to what that word should be because we're talking about the hypotenuses. This word hypotenuse can only be used when we talk about a right triangle. And we call this new shortcut the HL congruence postulate. HL stands for hypotenuse and leg. Even though we only use two letters, we still have to look for three things because we know that hypotenuses only exist inside of right triangles. So you first have to look for a right triangle, and then the hypotenuse is being congruent and the legs being congruent. So even though it's a two-letter shortcut, we still look for three things, and we'll see an example of this later on. In this diagram, triangle ABC is congruent to triangle DEF by HL. And just if you need a quick refresher, when I say hypotenuse, I'm talking about the longest side in a right triangle. It's always across from your right angle. And then when we say legs, we're just talking about one of the two other sides that touch the right angle. And then we have one more section on this page. This actually isn't a shortcut. Here we're going to list the things that will try and trick us all the time. Back when we did similar triangles, we learned about angle-angle similarity. So we've still got this AA thing in our brain, but AA does not show triangles are congruent. It just shows triangles are similar. The other one that's going to try and trick us, just because it's a set of S's and A's, is side-side angle or angle side-side. Again, that's not one of our shortcuts. So if you see two sides and the not included angle being congruent, it doesn't tell us enough information. All right, at this point, we can assemble this flip book. So it's pretty straightforward how to put it together. You're going to take each side and fold it in towards the middle, make a crease, and then you'll cut along the solid lines on the front to create 6 different flaps that you can open up to see the inside. Once you're done constructing this, I would recommend you put it in a safe place. For me, that would mean gluing it inside of my math notebook. All right, we'll do a couple of quick hypotenuse leg examples just because that's the new shortcut for us today. So are these two triangles congruent? If yes, I want to state why. That just means identify the postulate and write a congruence statement. When I look at these triangles initially, I see an angle being congruent. I've got 2 right angles, and then I've got 2 side pairs. So it looks like ASS, which is not one of our shortcuts. But from now on, before you say no, there should be a little light bulb that goes off in your brain that says, but could it be hypotenuse leg? So the 3 criteria for hypotenuse leg is, do I have right triangles? If you have right triangles, you can check, are the hypotenuses congruent? Are the legs congruent? So I do see right triangles because I have a right angle. If I look directly across from my right angles, that side should be my hypotenuse. And my hypotenuses are congruent. RM is congruent to FB. And then the third thing to check is, do you have another side that's congruent? Yes, we do. JM is congruent to DB. So we can make a conclusion that yes, these triangles are congruent. Our reason why is the HL congruence postulate. And our congruent statement might look something like RJM is congruent to triangle FDB. And you guys know this already, but you could have written a different congruent statement than I did. Your corresponding parts just have to line up. So if you started with like the letter M for your first triangle, then you would start with the letter B for your second triangle. All right, I think we'll do 2 more examples in this video. So here's our next one. Similar looking problem. Are these triangles congruent? If yes, state why and write a congruent statement. So I see 2 matching sides. I see a 90-degree angle. I can assume I've got another 90-degree angle because we've taken that straight line and we've cut it in half. And then this segment RT is congruent to itself. It's in both triangles. That's an example of the reflexive property. So it looks like these 2 triangles will be congruent. My reason is side, angle, side. And my congruent statement might look something like triangle RTS is congruent to triangle RTL. I specifically included this example because it has a right angle, but it's not hypotenuse-like. We can still use our other shortcuts even when we have a right angle. That's a common misconception. A lot of kids will think, well, there's a right angle. I'm not going to look at anything. I'm just going to guess hypotenuse-like. You still have to check your other shortcuts, and it's just when the other shortcuts do not work that we think, well, could hypotenuse-like be an option? All right, here's the last one we're going to do. Are these triangles congruent? If yes, state why, make your congruent statement. So I see 2 sides right away, segment MN and segment OR are the same. I see 2 right angles, so that's a matching angle. And then I've got this shared side. Segment ON is going to be congruent to itself. So when I look at the information I have, that looks like 2 sides and the angle not between them. So that's ASS. So initially I'm going to say no, that's not a shortcut. But then before I write no, I'm going to ask myself, but could I maybe use hypotenuse leg? Let's see. I have right angles. So I know I have right triangles. That's the first step. Then I have to look at the hypotenuses, the side across from the right angles. Those are congruent. And then step number 3 is, do I have a leg congruent, just a side? Yes, we do. ON was congruent to itself. So yes, these triangles are congruent. My reason why is the HL congruence postulate. And my congruent statement might say something like triangle MON is congruent to triangle RN.